Lesson 3.7, Solve Systems of Equations by Graphing. What will we learn today? To write and solve a system of equations by graphing, and to determine if the system has no solution, one solution, or infinite number of solutions. The main vocabulary word for today, or vocabulary term, is systems of equations. Systems of equations are two or more equations with the same set of variables. So here's an example, y equals 4 times x, and y equals 4 times x plus 2. You'll notice that both equations have the y, and they both have an x. This is a system of equations.
This is Mrs. Dawson. One solution. Solve the system y equals the opposite of x plus 4 and y equals 2x plus 1 by graphing. Let's graph one at a time. Notice both of these are in slope-intercept form. Y equals negative 1 times x plus 4 indicates to us that we have a slope of negative 1 and a y-intercept at 0, 4. So we'll plot the point 0, 4 and then move according to our slope. Down 1, right 1. Continue on. Or we could move up 1, left 1. And then connect these points with a line. Arrows on the end, and label this line. This one was y equals negative 1 times x plus 4. The other line, y equals 2x plus 1. The slope is 2, and the y-intercept is located at 0, 1. So we'll begin by plotting the point at the y-intercept, 0, 1, and then moving according to the slope. Up 2, right 1. Up 2, right 1. Or we could have gone down 2, left 1. Grab the line and connect the points. Arrows on the end, and identify this line as y equals 2x plus 1. We want to solve the system, which means to find the ordered pair that is a solution to both equations. Graphically, how we do that is find the point of intersection. These two lines meet at the point 1, 3. The solution to this system is when x is 1 and y is 3.
Hi, this is Mr. Rutherford. In this problem, we were looking at a real-world example. Food. Tanisha and her friends bought a total of 8 tacos and burritos. They bought 2 fewer burritos than tacos. Write a system of equations that represents the number of tacos and burritos. Solve the system by graphing. Notice here this problem asks us to write a system of equations. A system of equations is 2 equations. Notice here in the first sentence it tells us that Tanisha and her friends have bought a total of 8 tacos and burritos. Now, the number of tacos and the number of burritos are unknown, so we're going to use variables to represent those. So we'll say x is equal to the number of tacos, and we'll use a variable y to equal the number of burritos. Now it says that we have here that Tanisha and her friends have bought a total of 8 tacos and burritos. So if we add x and y together, it will equal 8. Notice here in the second sentence it says that they bought 2 fewer burritos than tacos. So that means that we can write an equation, the number of burritos, y, and we can say x, the number of tacos, minus 2. So now here we have a system of equations. It says that we need to solve this by graphing. Notice here in our second equation, this particular equation is in slope-intercept form, y equals mx plus b. However, the first equation is not. So let's put that into slope-intercept form. I'll recopy it here at the bottom. In order to do this, we need to subtract x from both sides to isolate the y. So we'll have y equals negative x plus 8. So our two equations are y equals negative x plus 8 and y equals x minus 2. So let's graph each of these. Notice in our first equation we have a slope of negative 1 because we have negative x, and remember that the slope comes in front of the x, which is m, and we have a y-intercept b of 8. So I'm going to first plot my y-intercept at 8. We have a slope of negative 1, so we'll go down 1 and to the right 1. Remember, slope is equal to rise over run. And because my slope is equal to negative 1, this is as if we have negative 1 over 1. So we have a rise of negative 1, so I went down 1, and a run of 1, so I went to the right 1. And we may want to do that a few times, so down 1 and to the right 1, and then we need to construct our line. So I do this by connecting our dots with a straight line and putting arrows at either end. Now we'll graph the second line, y equals x minus 2. So I started our y-intercept, which you notice is negative 2, and plot that. We have a slope of 1, so we can write this as a rise over run of 1 over 1. So in this case, because it's positive, I will go up 1 and to the right 1. And I'll do this a few times so as to make sure that I have a straight line. And I'll connect these dots and put our arrows at either end. Now, because we're solving this system of equations, we need to see where these cross. Notice we do have an intersecting point here, and that ordered pair is 5, 3. So what this means is, remember that our x was the number of tacos, so Teresa and her friends bought 5 tacos, and remember y is the number of burritos, so Teresa and her friends bought 3 burritos. So we have a total number of 5 tacos and 3 burritos. So now you've learned to solve a system of equations by graphing.
Number of solutions. We talked about number of solutions before, but this time we're going to be talking about number of solutions when it comes to the graphs of equations. So the graph of a system of equations indicates the number of solutions. If the lines intersect, there is one solution. If the lines are parallel, there is no solution. And if the lines are the same, there is an infinite number of solutions.
This is Mr. Hardesty. In our next example, we'll solve a system of equations. Solve the system y equals 4x and y equals 4x minus 5 by graphing. In our problem, we have 2 lines that will graph on the same coordinate plane, y equals 4x and y equals 4x minus 5. After we graph them, we'll analyze and see if the lines intersect, or they don't intersect, or perhaps they're the same line. First, y equals 4x. Let's compare both of those lines to slope-intercept form, which we know is y equals mx plus b, where m represents the slope and b is the y-intercept. our first line is y equals 4x. And if you'd like, you could add plus 0 to the end of that, so everything matches up with slope-intercept form. In other words, 0 represents the y-intercept for our first line. So we'll plot that here at the origin to represent the point 0, 0 on our line. Now the slope is m, the coefficient in front of x, and that says 4. That means we are going to go up 4, and then I like to put it over 1. We can see the rise over the run this way. So we'll count up 4 from our intercept, 1, 2, 3, 4, and then to the right 1. So this point, 1, 4, and the origin 0, 0 represent 2 points on our line, and now we'll graph that line. Our next line is y equals 4x minus 5. Negative 5 is our y-intercept. We'll plot that on the y-axis. The ordered pair is 0, negative 5. The slope, just like our first line, is 4, or 4 over 1, and we'll count up 4 and to the right 1. So the point 1, negative 1 is another ordered pair. And now we'll graph this line by intersecting those 2 points. And now we'll analyze our 2 lines. We can see that our 2 lines run parallel. Their slope was the same, so they will not intersect. We know to describe that solution as no solution, because these 2 lines do not intersect.
Hi, this is Mr. Rutherford. In this problem, we will learn to solve a system of equations by graphing. Solve the system y equals 1/2 x minus 3 and 2y equals x minus 6 by graphing. Notice we have 2 equations here. The first, y equals 1/2 x minus 3, is already in slope-intercept form. Just to remind you, slope-intercept form is y equals mx plus b. Notice that our slope of this particular line is 1/2, which corresponds to m, and our y-intercept is negative 3, which corresponds to our variable b. Next we have 2y equals x minus 6. This equation is not in slope-intercept form because we have a coefficient of 2 in front of the y. So in order to get it into slope-intercept form, we'll divide both sides of the equation by 2. So our y's will cancel, rather our 2's will cancel, and we have y equals, coefficient of x is 1 over 2. That will give us 1/2 x. Negative 6 divided by 2 is negative 3. So we have y equals 1/2 x minus 3 and y equals 1/2 x minus 3. Notice that these are the same lines. Let's go ahead and graph these. So first, we're going to start at the origin. We start with our y-intercept by going down 3 because it's negative 3 and place our dot. Our slope is 1 over 2, which gives us a rise of 1 and a run of 2. And we'll do this one more time. Up 1 to the right 2. Now we can connect these and make our line. So this is y equals 1/2 x minus 3. Now our second equation is the same because we rewrote it into slope-intercept form. So this line would lie directly on top of our first line. So because of this, our solution to this system of equations is going to be infinitely many solutions.
So now that you've just seen those last 2 videos regarding number of solutions, let's talk about slopes and intercept. Okay, when a linear system of equations has different slopes and different y-intercepts, there is one and only one solution. For example, these two equations, or this system of equations, y equals 4x plus 1 and y equals 3x plus 8. As you can see, they have different slopes and they have different y-intercepts. Knowing that, I'll know that I have only one solution for this system. When we have the same slope and different y-intercepts, there is no solution. Okay? So if we see the same slope but different y-intercepts, those are actually going to be parallel lines, so they will never intersect. Last but not least, if we have the same slope and the same y-intercept, there is infinite number of solutions, because actually they are the same equations. As you can see in the example, y equals 4x plus 1, y equals 4x plus 1, they are the same.
Welcome to McGraw-Hill Personal Tutors. A system of equations consists of two lines. One line passes through 4, 5 and 0, 9. The other passes through 6, 8 and 0, 14. Determine if the system has no solution, one solution, or an infinite number of solutions. To compare the lines, we can first write the equation of each line in slope-intercept form. So the first line that passes through 4, 5 and 0, 9, first we'll find the slope, and the slope can be found by the change in y divided by the change in x. So for this particular one, we have 9 minus 5 divided by 0 minus 4. So the slope is 4 divided by negative 4, which is negative 1. We can find the y-intercept for the line once we have finished writing this in slope-intercept form. So we have a couple options here. We'll go ahead and use y equals mx plus b, and choosing an ordered pair to use. Wow, this is convenient. 0, 9 is the y-intercept, so our equation will be y equals the slope, which is negative 1, times x plus the y-intercept. So y equals negative x, or the opposite of x, plus 9, which gives us our y-intercept at 0, 9. Let's go ahead and graph this one that we've started in blue. We'll plot the point 4, 5, and the point 0, 9. And connect those two with a line. The second piece of information we'll go ahead and do in red. So we have 2 points, and the first thing we want to do is find the slope. 14 minus 8 would be the change in y, divided by 0 minus 6, which is the change in x. So 14 minus 8 is 6, divided by negative 6 is negative 1. So we have a slope of negative 1. Oh, notice, the slopes are the same. That's important information. From here, in slope-intercept form, y equals mx plus b, the second ordered pair of 0, 14 gives us the y-intercept. So the equation will be y equals negative 1 times x, or the opposite of x, plus 14. Notice that the slopes are the same, but the y-intercepts are different. When the slopes are the same and the y-intercepts are different, that tells you that our lines will not intersect and the system has no solution. In other words, These two equations or lines do not share any ordered pairs. But let's go ahead and graph this second one just to make sure you can see that the two lines do not intersect. The points that we had provided were 6, 8, and 0, 14. And then we'll want to draw a line that passes through those 2 points. Because these two lines have the same slope but different y-intercepts, the system of equations has no solution.